Om Sri Sai Ram. My humble salutations to my beloved Bhagwan, respected elders, and my dear students. Hearty welcome to this model question paper special functions class. Now we are going to discuss the essay questions. Now prove that beta of m comma n is equal to gamma of m into gamma of n divided by gamma of n plus n. We know that the standard formula in gamma properties and the properties of gamma functions, we have learned that integral 0 to infinity e power minus ky into y to the power of n minus 1 dy equal to gamma of n divided by k power n. So here I am going to use the terms integral 0 to infinity e power minus zx into x power L minus 1 dx. That is nothing but the standard formula gamma at L divided by z power L. Therefore, gamma L is given by integral 0 to infinity z power L into e power minus zx into x power L minus 1 dx. Multiplying both sides by e power minus z into z power m minus 1, we have gamma L into e power minus z into z power m minus 1. That is nothing but integral 0 to infinity e power minus zx into z power e power minus z into z power m minus 1 into z power L into e power minus zx into x power L minus 1 dx. So the powers of e becomes now e power minus z into 1 plus x into z power L plus m minus 1 into x power L minus 1 dx. Now integrating both sides with respect to z from 0 to x infinity, we have gamma at x into integral 0 to infinity e power minus z into z power m minus 1 dz equal to integral 0 to infinity integral 0 to infinity e power minus z into 1 plus x into z power L plus m plus 1 dz into x power L minus 1 dx. The integration written within the brackets is nothing but now gamma of L plus m divided by 1 plus x whole to the power of L plus m into x power L minus 1 dx. So gamma L into gamma m is equal to gamma of L plus m into integral 0 to infinity x power L minus 1 by 1 plus x whole to the power of L plus m dx. That is nothing but we are having gamma of L plus m into beta of L comma m. So this is the standard formula. So beta of Lm equal to gamma of L into gamma of m divided by gamma at L plus m. So replacing L equal to m and m equal to n, we get beta m comma n equal to gamma m into gamma n divided by gamma of m plus n. Now prove that 2 power n into gamma at n plus half equal to 1 into 3 into 5 etc. 2n minus 1 into root 5, where n is a positive integer. We have gamma at n plus half equal to, I am going to put it in the standard formula, number plus 1. So I am going to replace the number as number plus 1. So n plus half can be written as n minus half plus 1. Now it is of the form gamma number plus 1. So that is nothing but number into gamma number. So n minus half into gamma n minus half. So n minus half into gamma n minus half. Once again I am going to put it as number plus 1. So minus 1 plus 1 I am going to add. So that becomes n minus half gamma at n minus 3 by 2 plus 1. So once again this becomes n minus half into n minus 3 by 2 into gamma n minus 3 by 2. Now proceeding like this, n minus half into n minus 3 by 2. Next term becomes n minus 5 by 2. So like that goes on. So we get 3 by 2 into 1 by 2 into gamma of half. So that is nothing but 2n minus 1 by 2, 2n minus 3 by 2, 2n minus 5 by 2 and so on. 3 by 2 into 1 by 2 into gamma of half is nothing but root pi. So by rewriting this as 1 into 3 into 5 etc. 2n minus 1 divided by 2 power n into root pi. So 2 power n into gamma of n plus 1 by 3, that is equal to 1 into 3 into 5 etc. 2n minus 1 into root pi. So I hope that is clear. Now 10a. Solve y dash minus y equal to 0 by power series method. So here the given equation is y dash minus y equal to 0. Let the solution of one of the power series is given by y equal to constant a0 plus a1 times x plus a2 times x square plus 1 a into x power n plus. So that can be written as summation a into x power n by x power n running from 0 to. Now differentiating with respect to x, we get y dash equal to summation a n into derivative of x power n is given by n into x power n minus 1. N running from 1 to infinity we have to write. Okay. Because when n equal to 0, the first term anyway it vanishes. So we start with, we don't get a naught term here in y dash. It starts with a1. Okay. Now substituting the above values of y and y dash in the above equation 1, we get summation n into a n into x power n minus 1 minus summation a n into x power n equal to 0. Now giving the values for this, when n is equal to 1, the first term becomes 1 into a1 into x power 1 minus 1. Anything power 0, 1. So it becomes simply a1 plus when n is equal to 2, it becomes 2a2 into x, 3a3 x square plus 1 minus. Now similarly start giving the values n equal to 0, 1, 2, 3 etc. The second term becomes a0 plus a1x plus a2x square plus 1, that is equal to 0. Now combine the constant terms, x square terms, collect all in groups. Okay. So the constant term a1 minus a0, x term 2a2 minus a0, x square term 3a3 minus a2 times x square plus 1, that is equal to 0. Since 3 is identity, we must have a1 minus a0 equal to 0, 2a2 minus a1 equal to 0, 3a3 minus a2 equal to 0 and so on. Now a1 minus a0 equal to 0 means a1 equal to a0. Now 2a2 equal to a1, that is 2a2 equal to a1 by 2. a1 is nothing but a0, so a0 by 2. Now what is a3? 3a3 equal to a2, a3 equal to a2 by 3. Now what is a2? So a2 is nothing but a0 by 2. So a0 by 2 into 3, that is 3 factor. So we are substituting these values into, we obtain y is equal to a0 plus a1x plus a2x square and so on. So a0 1 plus x plus x square by 2 factor plus x cube by 3 factorial. In other words, y equal to a0 into e power x, which is the required solution, a0 being an arbitrary constant. Next, find the power series solution in powers of x minus 1 of the initial value problem. Xy double dash plus y dash plus 2y equal to 0, y at 1 equal to 1, y dash at 1 equal to 2. So this is also very simple, just like the previous one. We are going to, instead of summation a n into x power n, we consider summation y equal to a n into x minus 1 whole power, and we can prove this. Okay. That I am going to discuss in the next class. Okay, thank you.